So we're going to talk about what you're going to do tomorrow, and then we're going to do what we're going to do today. You can move whatever tables you want. We did a group activity in 1A, so if you want to move things around to get back to normal, that's up to you. How about Jacob just got his computer out without me even realizing it?
Jake, I don't think ever put his computer away. You shut it. That's a different thing. Shut it and put it away.
So, here's your setup for tomorrow, and if you need it again tomorrow, it'll be recorded on my YouTube that you can go reference. But we have been asked to judge a water balloon contest. Now, fortunately, we've got all sorts of technology to help us out. There are little gizmos tracking the water balloons as they launch. So here's the actual setup. Every year, Newton High School holds a water balloon competition during halftime of their homecoming game. Each contestant uses a slingshot to launch a water balloon from the ground on the football field. This year, you are the judge. You must decide which contestants win the prize for longest distance and highest launch. Fortunately, you have a computer that will collect the data for each launch. The computer uses X to represent horizontal distance in yards from the goal line, and Y to represent the height in yards. So remember, there's a goal line on both ends of the field. So if I launch from the goal line into the middle of the field, I'm also going towards a goal line, but that's like, we're not like launching out of the field, right? We're launching into the middle of the field. You're in the end zone. I know we're not all like sportsy type people, but you're in the end zone.
Hey, I know what that is.
It's good. I still don't know certain things about certain sports, so I never assume anyone knows. This year, you must decide which contestants win the prize for longest distance and highest launch. It does not need to be the same person for both. So we'll have a winner for longest distance, winner for highest launch. It could be the same person. Does not need to be. So, all right, we've got Jen's everything, right? They give us everything for Jen. We can see how high her balloon went. We can see how far her balloon went. Great. So,
wait, 8 what? 8, is it like miles? Because that's
X to represent horizontal distance in yards from the goal line. Y to represent height in yards. So yards and yards, right? Lots of yards. The announcer shouts, Maggie Unanimous, you're up first. Maggie runs down and places her slingshot at the 3-yard line. Uh-oh. Maggie apparently missed the memo about line up at the goal line. So Maggie started at the 3-yard line. I think we're going to have to take that into consideration.
Yeah, she's disqualified. Don't need to do the math.
No, she's not DQ. We measure her launch from her start. I mean, just like all the doodads when they're playing football and they've got the thingies and the chains and they, like, whatever, the things that flip numbers. I don't know.
Oh, yeah, those things.
Yeah, see, now we're all on the same page.
He even watches the football and doesn't know what they're called.
After Maggie's launch, the computer reports that the balloon traveled along the parabola represented by the quadratic y equals a negative x squared plus 17x minus 42. Guys, obviously, I would hope that Mr. Johnson's my sub tomorrow, but always planning for worst case scenario. It could be a person who does not really understand math and is like, oh, it's middle school, I'll be fine. And then they look at my sub plans and they're like, high school math 2 quadratic equation, I don't know what I'm doing. And so I'm trying to set you up so they effectively don't have to do anything. And I also really love when I come back and my sub notes are like, oh my gosh, you get to teach the most amazing students. They were awesome. Like, they just got to work. They, like, wanted to do what they were doing. Like, so I'm going to give you the handouts for tomorrow before you, so like this sub tomorrow should essentially have to do like nothing, right? That's my goal. So, Maggie's launch, they give us the parabola, but that would only be so useful since we don't quite know what the pieces of the parabola mean yet. Hint, hint, nudge, nudge. Hint, hint, nudge, nudge. We might be doing that today. Wow. Might. Then you hear, Generous, you're next. So Jen runs down to the field, places her slingshot at the goal line. Ooh, see, she got the memo. And releases the balloon. The computer reports the path of Jen's water balloon with the graph at the right. Interesting. So they gave us the parabola for Maggie, unanimous. And for Jen Uris, they gave us a parabola here.
Wait. Yeah, neither do I.
Would you like...
No, are you talking about the name? I thought you were talking talking about the equation. I was like, I did not get that equation.
Oh, it wants me to prove I'm not a robot.
Are you? You're a robot, Mr. Hudson.
Yeah, that's why you're so smart.
Shh, don't tell it. Crap, I did just fail.
I feel like when you fail, it should be like, well, you're definitely not a robot.
They brought up the robot thing on the radio. Like, I was listening to the radio on the way to work, and they're like, yeah, just wait till Google asks you to prove that you're not a robot. And I was like, ah! Like, it just yelled at my radio. I was like, I hate that thing. Magnanimous is generous or forgiving, especially towards a rival or a less powerful person. So if you are described as magnanimous, that is a nice $5 word for someone who is generous.
$5.
Get it? Generous then is it. Sorry, that's like an appellation. There are like $1 words you're everyday, like whatever, and then like $5 words you're like, ooh, we're talking fancy now. It's like a $5 word.
But what if it's a $2?
So now it is. See, this is my warning to my guest teacher in the notes, is sometimes they act like they don't want to do math. It's now Impeccable's turn.
Wow, look at that.
Well, impeccable is not very
The
common.
other two kind of make sense, but this one just makes no sense.
Great. Hey, Imp, what's up, man? Like, that just sounds like an insult. All right, so the balloon launches. You hear a roar from the crowd. Turn around and splat! The balloon soaks you and your computer.
Wait,
You only have time to write down the following partial information about the balloon's path before your computer fizzles.
But it's water. What?
Water, if your computer's on, water's a no-no. If you turn your computer off and it gets wet, that's fine, as long as there's no electricity passing through it. So honestly, if your computer ever gets wet, just kill it. Like, immediately take the battery out if you can. If you can't take the battery out, shut it down, like hard shut it down. If your computer gets wet with water, you shouldn't have a dead computer if you get the power to shut off really fast. And most things are sealed enough that you've got a few seconds to like get the power to stop running through your computer. So your computer's dead now. And here is where the activity actually picks up, right? Of you having to do some things. So you've got this information written down about Impeccable's turn. Our final contestant, Altruistic, is about to launch their balloon. So Al releases the balloon from the 10-yard line, again, thinking that somehow gives him an advantage, not realizing we're just going to subtract 10 from his final result. And it lands at the 16-yard line. So we know how far did his balloon actually go? 6 yards. Way to go, Al. So, based on the previous launches, you estimate that Al's balloon was able to reach a height of 27 yards. Obtain a 5.1.2 resource page, which I will give you before you walk out of here. They are right here. And for each contestant, create a table and a graph using the information provided for each toss. But this will make a lot more sense if we understand, what this is representing, or how to take the information they gave us, like for Al, and actually turn it into a quadratic. So that takes us back to 5.1.1, where we have been hired
Cool. We're getting jobs.
at Functions of America. So congratulations, you have just landed your first, it's not a paying job, so you've probably had non-paying jobs before. I am sorry. Maybe I'll pay you guys on some candy. I guess maybe. So we'll make your wager. How about if we have a really good day tomorrow with a guest teacher, then on Wednesday I will pay you for your labor today for Functions of America. Does that sound good?
Why can't we just take a college credit?
Oh, yeah.
I mean, because I am not a college professor and could not offer you a college credit. If I could, that would be sweet.
Yeah.
Just give us all of it so we don't even have to go.
All right. Miss Frida Function has sent you this letter.
Wow.
Would you like me to try to do it in Frida's voice?
Yes, please do that.
Dear study team, I have heard that while lines and exponential curves are very popular, there is a new craze in Europe to have a U-shaped design. I recently visited Paris and Milan and discovered that we are behind the times. She doesn't know how to say Paris, Milan, she's close, but
What is that accent?
I don't know. I can't. She's like an old lady who's behind the times. She doesn't know how to do parabolas. Please investigate this new function, which is called a quadratic function. The equation for a quadratic function can supposedly be written in the form ax squared plus bx plus c equal to y. And the U-shaped graph is called a parabola. I'd like a full report at the end of today with any information your team can give me about parabolas. Spare no detail. I'd like to know everything you can tell me about the features of these graphs. I'd like to know about special points on a parabola and any patterns that exist in the table. The company is only as good as its employees. Your research is essential for the success of our new product line.
Right. The stress is not there.
Okay,
So, using Desmos or your graphing calculator or anything you want to do, we're going to try to investigate these 10 functions and figure out what in the world we can figure out based off the different characteristics of the functions. So, if you would like to divvy up the functions based off, like, similar information,
so on Desmos, how do we like use the just like normal
so just literally go to desmos.com.
And then
Don't go to student.desmos.com. Just go to desmos.com.
And then go to graphics.
And then click Graphing Calculator, which is a big green button at the homepage. So, like, one thing I would notice and potentially, like, divvy up to each other is, like, these two are really similar because we got a positive x squared, a negative b, and a positive c. Same here. Right? And, like, so I would probably have at least a person do all three of those and try to compare them to each other
I'll do it.
to see what we can figure out. So negative in here, right? Negative b, negative c, negative b, negative c. Negative a, got a negative a there, got a negative a here, got a negative a here. Remember that we can also try to factor these to write them in the other form. Because we said that factoring breaks up our quadratic and gives us the dimensions instead of the area. Guys, I would always have just the parent function graphed as well. What is your parent function? Y equals x squared is our parent function. So we would always want to have that graphed.
I figured something cool out.
What do you think you figured out?
I figured out that the constant doesn't matter for like the shape of it. Like it matters where it is, but it doesn't change like the. It doesn't change the y or the x of the like point of the parabola, whatever it's called.
So you're saying, so you're saying this doesn't change the parabola, like,
It doesn't change the center point of it.
well, it doesn't change the x value of my center.
Yeah, the x value. It changes the y value, but not the x value.
So really, hold on, before we move on, because we want to take all of these, but we're going to try to formalize all of this. So Connor, can you say anything more specific about what it does do?
It moves it along the y-axis. Like the intersection.
Give me more. Ooh, you're almost there.
The y-intersection?
The y-intercept
Oh, yeah, that.
is whatever our constant is. Right? Just like for a linear equation. Oh yeah, because that just modifies what the y is when x is 0. Right? So whatever this is, it just moved. But wait a minute. We've got one here. Negative x squared plus 4. So I'm going to turn these dudes off. Compared to the original, those are kind of bad numbers. Ooh, that's kind of a nice number. What I love about Desmos is when you hover over it, it'll tell you the numbers, and if you click, it'll stay there. So I get a 2 and a negative 2 there. That's interesting. All right, Jake, you were saying you discovered something?
Yeah, I discovered that if you make the coefficient of x 2,000, oh my god, and then you zoom out until the first unit on the graph is 1 times 10 to the 50th, and then you drag it up and down, the line flickers.
Fantastic. What does that have to do with the activity we're doing right now?
I don't think anything. That's really cool.
So I don't understand why you're doing that before doing what I asked you to do. So Jake, do I need to have you planted where I can see and keep track of what you're doing? Can you do what I ask you to do without getting distracted? These are genuine questions. I need you to answer honestly. If you can't keep yourself on task of what we're doing together, I have to do something to keep you on task. So while what you said might be cool, I do not think it is purposeful. So Jake, I would let us go down that rabbit hole if you could explain all the parts of the parabola to me and what they do and how it, like, once we get beyond that, I don't care what you just play with, right? I love when you guys just play with math. But give me something realistic, like when my coefficient is negative, or when my coefficient is like a number, or maybe even a negative number. Like, what can we say about comparing to the parent function? Guys, so a lot of times, look at what I'm doing. I am copy pasting a bunch of parent functions. Then I'm going to modify them. Right? Because it's easy to get that x squared if I just copy paste, Control C, Control V. So I think I'm going to throw my blue. No. What functions do you guys want to try? Up on the board.
We could try what's the difference between the yellow ones? It's a change in like the amount of x. So we could try the yellow ones.
So here's the yellow ones. X squared minus 4x, x squared minus 6x, and still the plus 5s. And then
I have no idea.
x squared minus 2x plus 1. So hold on, if I turn this one off, because it seems kind of out of place, and if I turn the parent off for a second, the only differences between these is blue has negative 4x. This has negative 6x.
And they still have the same y in it.
I have no idea if this helps, but one of the equations on CPM was y equals x squared minus 2x plus 1. I made another parabola that has this same, it looks the same if y equals parentheses x minus 1 parentheses squared. I have no idea what that is. If that makes sense.
Why is that interesting? So remember, instead of difference of squares, we have a b on a perfect square. So wait, this was, hold on, we're still trying to get what Akshay said up here.
Parentheses x minus 1 and then squared.
So how we say that is quantity x minus 1 squared. So saying quantity of essentially tells you that there's parentheses there. So we would say the quantity of x minus 1 squared. So something interesting I see there is x minus 1 has this point 1, 0.
We talked about that on Friday.
What if I test this and say x minus 4? Ooh.
That's how you move them.
Yeah, we talked about this
So wait,
on Friday.
if we do x plus, crap.
If you do x plus 4, it's going to go to the left. No, yeah, left.
Ah.
So that's how you move it side to side.
What, Jake?
That's a perfect segue. What I was going to say is that when you add x to it, like just this plain x, like the 2x or 3x equals x.
Like here?
Yeah. No.
So get it back in the trot like this?
Yeah, y equals x squared and then plus some amount of x.
Oh, yeah, that's going to move it up and down. I don't know.
Well, it does that too.
y equals x squared plus some amount of x. Okay.
So it,
Oh.
yeah.
What? So you can't just say yeah.
Wait, can you go
So
down?
it moves the point to the left on the coefficient of x if it's positive, if the coefficient is positive, or to the right that amount if the coefficient is negative.
Does that work when there's a constant here too?
It looks like it.
Ah, crap.
But the constant might influence like the thing, right?
So wait, kind of like what Akshaya just said, can I rewrite this in another form that might be the same thing? Can something factor out of both of these?
X squared. 5x.
Keep stabbing, you might actually hit
X
something.
squared plus 5x. It's just both be y.
What can factor out of both x squared and 5x?
Oh,
Three,
X.
X!
Oh.
Right, guys? So if I turn on and off blue and green, they should be the same graph.
Whoa, that's.
I can also turn it into a dotted line so I can see the one behind it.
The dots are too thick.
I know, the dots are kind of too thick. But if we zoom in, we can see that both lines are there. So, wait, kind of like...
So it's like factor.
So wait, it doesn't matter if this... So this gets like squared there. But it did the whole move over like we wanted it to. Here, so this creates this point. Can we take one of our more complicated ones and factor it?
Okay.
Like, can you look at any of these and say, oh, well, that's factorable? We would like a larger, like, constant, right? Are any of these, like, nicely factorable?
B, I think.
Oh,
Negative x. What? No.
Ooh, the negative x squared is weird. I'm going to graph that just to see what the heck it looks like.
I think it flips it upside down.
Yeah.
Negative x squared. Oh, so that coefficient flips it? Yeah. The negative x squared plus 4 ends up... But we still have 2 and negative 2. And compared to, like we said, just positive... Wait.
Why does
Now
it
it...
look
Oh, because the y-intercept's at 4.
Oh, yeah, y-intercept's at 4. But if we mine... Well, then that's a different equation. Ooh, but they, look, they're like
They
symmetric.
have the same, yeah.
Ooh, they're like reflected. It'll look nicer if I do that. Yeah.
If only we could figure out how to make them like 90 degrees sideways, then it would look really cool.
Oh, you mean...
Mr. Hudson knows I didn't do that.
Yeah, he told us yesterday. But
Wait, is it like
Yesterday was not a school
oh
day.
yeah, Friday. That's what I meant.
Yeah, we were all here yesterday.
Like how Connor's not paying attention now.
Oh, I see.
Wait, then do plus 4 after that. Okay, wait.
Minus.
Alright. Oh.
Yeah, it has to be.
Into
Oh,
the
yeah,
sun.
minus 4. And then you have to do another one. Plus.
That again is going down the rabbit hole that we shouldn't go down yet. I know, right? I know. We'll go down there eventually. Don't worry. Can we factor the negative 2, negative 8?
2 or negative 2.
Yeah. But we can't factor the x squared by that. So we could do x squared minus 2 x minus 1.
Wait, we can... Yeah, this is fat. Wait, what'd you say?
We could do x squared minus 2 times the quantity of x.
Wait, no, that whole thing is factorable.
Wait, the whole thing?
Yeah, we can factor that into 2 binomials.
Oh.
X plus 4. And then times x.
You sure about plus 4?
X minus 4, x plus 2.
Or no, minus 4 plus 2. Yeah. I think.
So this, x squared minus 2x minus 8. This is the same graph. blue is the same graph as red.
Yeah. That's cool.
Oh yeah, because it's
But, okay, so -2 and +4.
yeah. That seems to be like a consistent thing.
Oh, it
Whatever
looks.
you put is kind of
Wait.
what it is.
Ooh.
I want to play with
If
this.
you do -2. Oh, I
I'm just playing with this, but any hypothesis of what should happen?
Can you see the
It'll
plus
be
degree?
-3 and positive.
Yeah.
It'll be -3 and +8.
Yeah, because
Like all
I don't
of
know how to explain that, but it's like the opposite number of the. I forget what those are called. Minus.
What is this called?
constants.
What?
They're called constants.
Okay.
Hmm.
I think I.
Yeah, it works for really big numbers too.
Is this one factorable?
Yeah, 3 and 2. Or wait, let me think. What?
It's not 3 and 2.
No, it's not. It's 5 and 1.
Both negative, right?
Yeah, I know.
So x squared minus 6x plus 5. So wait, you just said this is factorable to -5, -1. So -5, -1 would tell us +1, +5.
Whoa.
Whoa! Wait. I feel like I could do something with that, but I don't know what it is now.
Can we factor this?
Yeah. 3 and 5. -5 plus
Negative 5 and positive 3.
-5, +3. So hypothetically, when I type that in, we already know where it should pass.
+5, -3. Yeah. Yeah.
+5 and -3, you're thinking?
Yeah.
Getting good.
Interesting.
So wait, let's take some notes.
Like, how do you know it's? How did you?
Because
know
it's the
positive?
opposite.
No, how do you know the 5 was positive?
Because it has to. No. What?
How do you know it wasn't?
Let's take some notes so that we can answer these questions that we're slowly starting to form.
I don't like that.
I don't mind.
But generally, I just don't
Wait,
like.
so
school.
what's the homework for today?
Yeah, whatever lesson we're doing.
Okay.
511.
5.1.
For a second, I had to think way too hard about what we're doing.
So 5.1.1.
Yes. I will change that board hopefully by tomorrow. So I'm going to grab this one because it's down at the bottom. Just because I have somewhere to write down here. We said this factors into.
Well, I said.
Well, math says, right? Like, if we think about FOIL, right? Or if we think back to the diamond and the rectangle method. Gee, notice how we're all holding pencils? I know there's more exploration to be done. Ooh, absolute value graphs. Getting curious. Or if that's not an absolute value graph, then I am curious how you graph that.
Wouldn't it be? Yeah. Well, can't you just do?
Well, what does x squared equal y squared really mean? But hey, stop with the play. Get out a piece of paper. So we said this passes or like goes through the x-axis at x equals -3 and +5.
Wait.
Guys, please don't let yourself be confused when we start to write lists like this or sets. That is not a point xy. That is multiple x values. Right? So we start to write sets like x equals whatever comma, whatever comma, whatever comma. Like,
Without the parentheses.
and if there's only two of them, yeah, and actually we'll use set notation soon, which doesn't use parentheses, it uses like brackets. But this is, so set notation,
Oh yeah, I know what those.
just use the fancy brackets. But you don't have to. It's just one way to say these numbers are contained in my set. Interesting. Can we figure out a way that that works when we have a negative x squared, like what we've highlighted in blue?
Wouldn't it just be very simple? So like positive 3 and negative 5?
No, I mean like one of these where the x squared, like out here, where a is negative. Because it doesn't factor as easy, right?
Wait for F.
Man, I might just want to think like this. Negative 4x squared and a 3x. I'm curious if that works.
Negative 4, no, 4 minus 1.
Ooh, 4 and a negative 1, isn't it? But when I think about the rectangle, my x squared is negative. So 1 and 4. Just stick with me here, thought experiment. This gets me negative 1x. Right? This gets me 4x. It gets me negative x squared. Yeah. Yeah.
Yay!
Okay, but wait, put that in Desmos.
Yeah.
Like the binomials. I have a million Desmos tabs.
Okay, so the points are negative 1, 4. Yeah, they work.
It's the same as if you just put there.
Yeah. Wait.
Even with the negative x?
No,
Wait,
no,
did you get
no,
one
the 4 is the same. That's not right.
Wait, did you get 1 and negative 4?
I got negative 1 and 4.
Yeah, I got that.
So if there's a negative in it, that means it just stays the same. Because that's okay.
So we got negative 1 from here. Positive 4. Ooh, wait. Ooh.
Right. So if you put negative in the other one, so if you did put the negative in the other x, then it would be 1. I guess. Yeah.
Would the negative and the other x work to do the same parabola?
Oh no, because
Well, I don't know. I'm genuinely asking.
no, because it's tried it and
Oh, it's a different. Oh, because it foils out differently.
yeah.
Yeah, if we moved where the negative x was, that foils differently. So that has to be here. We can see it from being a different parabola. Guys, what does it mean when something is quadratic? It's actually not what that means.
So it means it has 4 of those.
I mean, so you're right. Like, if you Google define it, right, involving the second and no higher power, yes, sure. That is what we're talking. But what does it actually mean? This is like when you can tell kids cheat on tests because, like, they couldn't explain the definition they wrote down. Like, which not you guys, but... Oh, well, okay, so this helps us understand a little bit more. A variable multiplied by itself. So whether it's x squared, y squared, h squared. Jake, you still with me? Okay, and if you're digging for what's quadratic mean, that's totally fine. So here it says, comes from quadratum. Ooh, now there's more fun. Latin word for, ooh, there you go. This could win Jeopardy sometime. Latin word for square. Quadratum. Oh, come on, quadrilateral, quadratum. So, but wait, which is a quadratic equation?
That's not correct.
A quadratic equation, an equation of the second degree contains at least one form of the squared. Oh!
Wait, that's how you find the x values. Those are the x values.
Wait a minute.
That's why when you did
Google just got
copy.
it. Like,
Oh my
Yeah,
god.
because I totally didn't know that until I Googled it.
yeah. Was that what you were looking for on Google?
Trust me, I planned this all out.
You planned Google?
Yeah.
You always Google?
parabola is different than a quadratic because a quadratic equation equals 0.
Oh, and I typed it in its parallel lines.
Wait, typed what in it in its parallel lines?
I did the equation for the parabola and then made it equal 0 in its parallel lines.
Whoa.
Interesting.
Wait, what?
Observe. So,
I'm just gonna do it on my own computer.
Yes. Wait, hold on. Write this down.
Okay.
Write this down. Hands off your keyboard. Write this down. We have to wait to be dismissed till lunch today, so I'm not worried about running out of time, but still. If we have two things, let's just call them A and B. If we have two things, let's call them A or B, that multiply to equal 0,
Oh my gosh, it's a conditional statement.
Wait,
then either, what? Either A equals 0, B equals 0, or So then, guys, look up here real quick. When x minus 5 is set equal to 0, what x value makes it equal to 0? So when x plus 3 is set equal to 0,
It's -3.
so,
Oh my
but like,
God.
when negative x plus 4 is set equal to 0,
It would be 4.
it's negative x equals negative 4, and
So then it
that's
gets
why it's positive
But
4.
then when x plus 1, if that equals 0, wouldn't it be -1?
That's what it was.
Oh, yeah, it is.
silly Connor.
Yay! We just found something in this.
So if we know that imp, if we know that imp, I think he's got like a health issue.
No, I thought you were talking about like a math, like IMP stands for something.
Impeccable.
Equable, are you here?
Wait, maybe I wasn't meaning imp. I'm getting the words mixed around.
Generous.
Who
Magnanimous.
starts at the 10-yard line?
Oh, owl.
Altruistic.
Altruistic, yeah.
So altruistic, and this is me like helping you guys a little bit for tomorrow, starts at the 10-yard line, lands at the 16-yard line.
And we just
So what does that kind of, if we know that like the graph is going to look like, then, so these points we just said, we could kind of start to build a function of this by writing down
X plus 3 and X plus 2 or minus 2 or something.
a 10-yard line and 16-yard line.
Well, those don't matter.
So it's 10, 0, and 16, 0.
This would be the 10-yard line, and this would be the 16-yard line. So really it's x minus 10, x minus 16. Okay, go ahead and put that in Desmos, because it's wrong.
Wow. Why do you have to tell me that before I put it in?
Because it's more fun that way.
Yeah, that's wrong. It's negative x plus something.
Oh, yeah, that's not going to be pointed the right direction.
It has to be negative.
One of them has to be negative.
Wait, what?
Perfect. I did it. I'm amazing.
Connor's so cool.
Yeah.
But wait,
Wait, but which one?
One of the coefficients, one of the constants has to be positive and one of the x's has to be negative.
It has to be the same.
So one of these has to be... Is there another way that we could make the function negative?
Wait, it works the same way? Oh my goodness.
Ooh, that didn't work.
Hey, I found it.
I found 2 ways to do it.
X minus 10 times negative x plus 16. That works.
So you made this negative, but then made this positive. Is there any other way to...
Yeah.
Oh, no.
I figured out 2 ways to do it.
That seems cheap.
It just has to be on both sides. So like, wait, no, that's not, no, I don't
Yeah,
like
I was
that.
gonna say you could put a negative on the outside.
I don't
Make
know
an
what-
argument that my way is not better than your way.
I'm
I would like
my
you to
way is
prove me
more
wrong.
exact.
Hmm?
It's better I just
My way is more exact.
Are they different, mathematically speaking?
Because mine's more exact.
If, hey, check it. If I distribute this negative first, right? And actually, sometimes we can
Oh, it would just
sort of do order of operations in whatever order we want, depending on if they'll mess each other up or not. Right? Like commutative property says we can move some things around and do. If we distribute this negative, negative x and positive 10, right? So this I could also write as negative x, positive 10, or if I distribute that negative but I had my binomials in the other order, negative x and positive 16, also the same graph, or I could just put a negative out here.
Yeah, but the blue and
But-
green were exact.
We're still wrong,
Oh,
right? They told us that Al hit a high value of 27.
You add more x's.
Wait.
no, you just add 27 to the whole thing.
Just add 27 to the
add
whole...
14.
Yeah. I think.
Ooh, that didn't work.
I think you have to add 14.
Oh, right.
Wait. Oh.
Why?
No.
But that moves the zeros, too.
I got it. So you have to put a 3 next to the negative sign outside of it.
Wait, why?
I don't know, but that worked.
Where does Al's balloon get to with the
Oh,
function?
it's at 9, so multiply the 9 by 3.
So let's remind ourselves, this function is generating the output value. So, hey, give me your eyes up here real quick. So this is the math being done to calculate y, right? We've got this where we want it, we've got this where we want it, and the y's are correct. And if I mess with a y that is 0, with multiplication that is, nothing happens. Right? If I multiply 0, nothing happens. So Jake says if I look at this y, which is the y that I care about, it needs to be multiplied by 3. So let's go ahead and say 3 times.
You did it.
So now, Al's balloon got to where he wanted it.
Hey.
Tomorrow, not today, tomorrow, your task is to graph everybody's water balloon manually on this piece of paper. But, guys, you can do it just by sketching 3 points. And really, 5 points is better. But if we wanted to graph Al's launch right now, hint, hint, nudge, nudge, you kind of are going to have a head start for tomorrow. We know where Al's balloon launches from and where it hits. So we know Al has his balloon launching here. We know it goes to the 16.
We go to 13, 27.
And we know the peak of the balloon is halfway. Right? So what number's halfway between 10 and 16? Oh, 13. So we know things peak halfway. It goes up to 27. So guys, if you wanted a couple more points to make this nicer, pick some numbers in between, like 12 and 14, or 11 and 15. Right? If you want a couple more x values, for Al, I would give a couple more x's, but like our x is going to start at 10, right? And it's going to stop at 16, so 11, 12, 13, 14, 15, 16. Ooh, I could fit them all on. 11, 12, 13. 13 I already know is 27. 10 we already knew was 0. 16 we knew was 0. do your directions for tomorrow make sense?
I think we'll be able to figure out the rest tomorrow.
You may use Desmos if you want, but your main objective here is to fill out this worksheet based off what you know. So if we can figure out a way to factor this, I think that would help us.
So wait, hold on. Maggie's water balloon runs over the 2-yard line doesn't exist because Maggie launched from the 3-yard line.
Yeah. That's why the 9 doesn't exist on this. Oh. Wait. Yeah.
Are we sure we got?
Yeah, you're right.
That person is scary.
So wait. Maggie launches at the 3-yard line? Oh. You're right.
Negative. Wait, that doesn't make sense. Like mathematics.
Well, even though it wouldn't make sense, like, what does the mathematical model tell us? We can solve that, right? So really what we will end up saying is this answer doesn't make sense. It means her balloon has not been launched. Does that make sense? Like, when you get a math answer that doesn't make sense, it tells us something. It doesn't make sense for a reason, right? Like, there is a reason things don't make sense. So here's my last tip of advice, because I don't want to tell you guys too much. What was the easier way that we dealt with trying to flip a parabola over? Put the negative way out front, though. Like, factor out the negative. Here's my advice. If you want to start working these things back away from, like, the really difficult point, if I factor out a negative here, then I have positive x squared minus 17x plus 42. And that is probably just as manageable, if not slightly more manageable, because both of my x's will be positive, than what I started with. And I can right now ignore this for the time being. Or both of my x's could be negative. But if both of my x's are negative, neither of them have to be negative. Because remember, there are multiple ways to write the same thing. So if you make both x's negative, what that actually means is neither of them would need to be negative if you fix other parts of the situation.
What if you like just being a negative kind of person?
I mean, you can leave that x as a negative and factor it that way. Just one of your x's would be negative. You have to remember to carry that opposite through the problem to the other pieces, right? So like if you're foiling, it goes to not only the firsts but also the outsides, right? So be careful.
Yeah, the foil's the one
I
where
feel
you
like
like,
there's something like we're both about to get, and then it's like I just can't get it.
Man, I wonder if that's intentional.
guys, I figured out the easiest way to solve for the x value.